So welcome everybody to part 3 in our next generation privileged identity management series. Today is on protecting cloud management APIs, and I'm joined by John Suit and Sean Hank. John is our CTO, and Sean runs all of our systems engineering activities globally for the company. John and Sean are back in the Washington, D.C. metro area, and I am today in sunny San Diego. So I got the, I guess I drew the good straw on this one. I'm out here actually for the Gartner Catalyst conference, where they're giving a fair amount of coverage to the whole privileged identity management space. In fact, I think as we're on with you now, Nick Nichols from Gartner Technical Professionals is giving a presentation on that topic now with a particular area of focus on cloud. Unfortunately, I'll have to listen to the recording. Which does remind me, we will be recording this, and like always with our webinar, sending that out to those who attended, so you can share it with your friends. So without further ado, we're going to get started. I'm going to do a little recap here at the front, and then John and kind of cover the why you need this kind of protection, and talk about a cool announcement that we just made, and then John's going to pick up and talk a little bit about the capability that we just, that we'll be announcing here, and Sean is going to take us through a demo. So that's the quick tour of how we're going to progress. So in our first 2 sessions of this 3-part series, and we spent a lot of time talking about the risks that privileged users provide, and those aren't new risks per se. I mean, the ideas of system database and network administrators, providing some extra risk that you need to manage in an environment that's been around for a long time. What had changed, though, is a couple of things. Certainly with the advent of cloud computing, virtualization, etc., we introduced things like management consoles. We effectively extended and expanded the whole management plane. There's some additional risk surface area, if you will, that you end up needing to protect. So we spent a fair amount of time talking about what that looked like. But the cloud environment, a virtualization environment, also has some other dynamics that we wanted to dive into, or we covered some of them, and then we're going to talk about the last piece here. So the conclusions that we came to as we talked about how privileged identity management has changed in the era of cloud computing and hybrid cloud environments, where organizations are using a combination of traditional equipment installed on-prem, equipment installed in a virtualization environment on-prem or in a shared data center, for example, or true cloud computing, infrastructure as a service, platform as a service. Those are enterprise customers are using lots of those, and also including SaaS applications. So we also talked last time about how we've extended our X Suite product to deal with Microsoft Online, Office 365 suite of products. We came to 3 conclusions, though, as we went through that. This next gen set of requirements is one, that you really need an integrated control set. We kind of call this the table stakes of PIM. If you don't have the kind of controls all in a single product, that you basically have a lot of headaches. You end up using a lot of your operational bandwidth just to keep up with configuring the various different products and getting them to work together, and certainly that isn't where people need to be. So the second piece of the requirements was really that you had to be able to protect these new systems wherever they lived. If they live on-prem, if they live in a virtualized environment or a cloud environment, you need to be able to protect those. And again, we talked about the cloud console. So across the hybrid cloud environments ends up being an important requirement as well. And the third one that we talked about was that these tools really need to be architected specifically for a truly dynamic cloud environment, where you can spin up new servers with a couple of mouse clicks in a couple of seconds. And one of the examples that we gave in this architected specifically for was the idea of not just being able to, for example, auto-discover that a new server showed up, but the ability to auto-provision that server with a set of policies so that it doesn't go unprotected for any amount of time, and B, security people don't have to go hands to keyboard every time something new shows up in the environment. In the cloud age, that happens very quickly. But there's another element to that, and that's the APIs, and the second element, if you will, to some of this, architected specifically. There's a whole lot of those things, but our second example is really going to be talking about the API. But before we jump into that, we just wanted to, walk you through how this looks. So, in a scenario where you've got a software-defined infrastructure, also gets to call, we've heard software-defined networking, software-defined data center. I think the market's still deciding exactly what to call those set of things, but we've been terming it software-defined infrastructure. You have these management consoles which provide enormous power. Not all of that's bad. You want to make not all of it's bad at all. It's these things are awesome from an operational standpoint, and even from a security standpoint, they're awesome tools. For example, you can get near perfect optics into your virtualization and cloud environment, something that security professionals for years have always wanted. Having a clear picture of the configuration of your environment is basically the first step in terms of locking it down. What do you have out there? How do you need to protect it? How is it configured? Is it up to the right standard, et cetera? And that was always very difficult in traditional data centers. And people could plug new things into the network, the old server under the desk, or a Wi-Fi hotspot, somewhere in behind your perimeter. Always bad things. In a cloud environment, you can't do that. In a virtual environment, it's a bit more difficult as well. So this idea of rapid infrastructure configuration is a really important thing for security as well. And the last was ability for real-time monitoring of these environments. Not just from a security perspective, but from an operational perspective as well. So they have some huge benefits in operations as well as security. But again, they come with an attendant level of risk. If I can go to the AWS Management Console, for example, and fire up 100 new servers, or delete 10 of them, or copy some of them off, those are the kinds of activities that can truly wreak havoc on an organization and cause real pain. So if the way I like to think about it is the management consoles end up being kind of the front door to your infrastructure environment, and if that's the case, you've got another garage door, big, large opening, is part of this risk management that you need to consider, and that's the APIs. So in a cloud world where things move really, really quickly, a lot of folks aren't just using the management consoles, the web-based interfaces that are provided by the various vendors, VMware or AWS, for example. They're actually using APIs where one server or set of servers is dedicated to basically firing, monitoring the environment and scaling it out when it needs to be. So it's not the case anymore that people are just going hands to keyboard to mucks with the configuration anymore. And what we're also seeing is that is happening at the advanced shops in a very, very big way. So we often talk about APIs, and typically the first thing that conjures up is a developer, maybe in your applications area, building, writing to an API to get data out of a database, for example. And this set of APIs that we're talking about is really all about the infrastructure management. And there's a couple of different patterns that we're seeing here. Certainly, a homegrown set of scripts or programs is one pattern that we're seeing. Some of the very large, cloud organizations that are making heavy use of the cloud have really gone down that path in a big way, and are developing their own programs, talking with these infrastructure management APIs to interrogate the environment, find out is it performing as it needs to be, do they need to spin up new servers, et cetera, and then actually making some of that happen all in a very automated way. But we're also seeing another thing happen, which is the collapse of development and operations. It's being called DevOps. So there's a new class of tools, things like Chef and Puppet, that have cropped up that use those same APIs to configure the infrastructure that your homegrown programs will. So there's homegrown stuff, and there's new tools on the market out, just for that. So that really is basically provides some additional risk surface area, if you will, that you need to protect. And because of that, we've announced actually today, this is the first time that we're talking about it publicly, a new capability within our X Suite product. So we've added some capability to enable X Suite to protect the API calls that are made to the management infrastructure. And what I'll do now is turn that over to John, and he can kind of take you through how that's working, and then Sean will follow up and show you it live.
Great. Hello, guys. So the idea here is that we wanted a way that we could transparently provide, control, audit, roles-based permission policy to the application interface infrastructure for AWS. Yeah, and to that end, what the really important takeaways are is, in our implementation, we did it in a way that's very, very transparent to the operations, running your infrastructure. So instead of, building out a whole, set of, credentialing and, separate from AWS and the like, where you need, proprietary formats and things like that, what you can do is very simply get a key pair and URL just like you do today from an X Suite server in your AWS environment, meaning you check it out, or we can programmatically provide access to it, and it will allow you to send all your API requests, API actions the exact same way you do today. So the format of the credentials are the same, the URL format is the same. You simply just plug it in like you would plug in a new set of credentials and URL into your Puppet, into your Chef, into your SDK of choice, into your script, and then you're off to the races. And what it does for you is it allows you to track each individual and unique script or programmatic or even manual, CLI-based API interface into AWS. So you'll know exactly whom or, what programmatic interface is doing the actions. A couple of customers who both experienced problems where they had incurred a tremendous amount of costs because a couple of scripts went, I won't say haywire, but they took action based on an event that they interpreted, and they spun up several, machines. In one case, 100 machines, in another case, over 1,000, and it did that because that's what it was programmed to do. Well, they didn't know who did it because they gave out shared credentials that they got out of the AWS admin console for the REST API usage, and they had no way to track it, let alone have a recording or really any way to audit that. And so when we first set out to do this, and if we could go to the next slide, that would be great. When we first set out to do this, there are a number of items we said this has got to be able to handle. So, right off the bat, you need a way to have a single point of access control, meaning I want to assign policy, use the X Suite Universal Policy Manager that we use for everything else in the same way, so I don't have to have a lot of disparate systems. And I can, from a single point, say, you know what, I want these individual users who are working on scripts or setting up programmatic access to AWS, I can give them a unique credential. That way I can track them. But I can do it in such a way that I don't have to do a bunch of work in AWS itself. I can do it from a single place. So I can set them up for a VMware infrastructure. I can set them up for like the vSphere client, for example, their access to that, or the AWS admin console. But when it came to AWS, the REST APIs, I wanted to do it in the same way. So I don't have to go in a bunch of different places, and I don't want to have to replicate user repositories. So I need to be able to federate access into the REST API infrastructure so I don't have to create a bunch of IAM users in the process. So when we went at this, the first thing we did is we actually talked to the AWS IAM team and said, what of your, of your infrastructure can we leverage to get this done? And they were extraordinarily helpful. And so what we did is we used their ephemeral credentialing manager in order to gen credentials on the fly so that we're not giving out real credentials to your scripts anymore. So you don't have to actually give out, for example, a key pair and URL that will give them direct access to the APIs. So that's the first step. And the way we do that is we generate a credential, we have a set of credentials, we generate a URL, and that gives you a certain level of access that you and our product describe through our permission policy manager to say, you know what, I just want this guy to be able to request information, like described instances, for example. I don't want them to be able to spin up instances or even have access to CloudFormation or S3 if I don't want them to. But I don't want to have to create all those IAM users. I want to be able to do it in a single place so that I know, John, he's going to create a chef recipe, and he is going to have access to do certain things and certain things only. But I also want to be able to record everything that happens. I want to be able to audit all of that, and I want to be able to correlate that information later in order to make determinations on what I want to do. So what you're seeing here on the slide is a list of items that we figured and found out that we had to do in order to accomplish that. So, things like attribute the AWS API activity to a specific user. And when we say user, what we really mean is it could be a script, it could be CLI API access, it could be an SDK that's tied to a human that requested that credential. I think the thing to really be explicit about is no one will have actual credentials to the APIs. They come to us, and let me describe what us means. That's an API, what we call the AWS API Proxy server. It's running in AWS. It is built with full load balancing. It's built for auto scaling on the AWS infrastructure. So you can throw more and more and more requests at this thing, and it'll leverage all the AWS infrastructure to keep up with the load. It works really, really well. And while it's doing that, it's recording all the activity, and enforcing a permission policy on all of those API actions in real time. So what you can do is say, you know what, I need to know who's accessing the APIs right now. I see a session just finished. I'm going to jump in and I can watch the recording of that. And we figured customers are going to want to be able to correlate these things. So in the demo you're going to see today, we chose Splunk, so you can kind of see what that would look like for those of you who have Splunk environments, for example. Some important housekeeping things. If you've been to all three of these, you know what we do in terms of vaulting the credentials in our FIPS 140-2 and level 1 and level 3 type vaults. But it's important to note we're also vaulting the static credentials that you get for your scripts, which by the way can be rotated by using our A2A technology and managed with our A2A technology. But we're also even storing that ephemeral credential, the one that really works with the AWS infrastructure, in our vaults as well. We always get a couple of questions with some beta customers that we had beta that with that, so I wanted to mention that. Can we have the next slide? Okay. So this is the reference architecture that we thought would be best to depict how this works. And there's a few things going on here. You're going to see that this operates with an X Suite AMI, which is our baseline product, in an AWS environment, as well as the Xenium X Suite API Proxy. They're both running as AMIs, and the X Suite X API Proxy will auto scale, like I mentioned, and this is how the infrastructure looks. A couple of things to mention. So this works with multiple accounts and multiple regions. We've gotten a number of questions on, can I manage EC2 instances via the API in multiple regions? Of course you can. Can I manage multiple accounts? You absolutely can, and they can all be directed to the URL that is our XAPI proxy server that's running in Amazon. If you look a little closer at this, you'll see this reference architecture depicts everything running on Amazon. It's not necessary to run the X Suite AMI in Amazon. You could actually run it as a VM or OVF if you wanted to. You could run it. You could use one of our hardened physical appliances if you wanted to. And we have reference architectures for those to set up the the networking, meaning you're VPNing into a VPC in order to manage your XAPI proxy engine. It's very easy to do. So to step back just a little bit, I think the easiest way to describe what we're really doing here is we allow you to get a key pair and URL from us. You put that into your Puppet, your Chef, your Python SDK, your Java SDK, whatever you're using, even in your either config file or right in line with your CLI API tool. You're doing everything the way you do it today. It's not going to look any different. What's actually happening is those requests are going to us instead of directly to Amazon where they can't be audited and can't be recorded. We're obviously able to validate those requests, enforce a specific permission policy that you set in a product, which also is very easy to do. And then as that permission policy is being enforced and everything's being recorded, it's available for audit as soon as it's completed. So if we go to the next, actually I think the next slide is ready for Sean. So Sean, if you could show that. Sean's going to show you a really brief demo because a lot of this is all happening under the hood. There's not a lot to show other than the output. So you can imagine, and I think we've asked Sean to do a couple of CLI commands like describe instances and things like that, so you can see what it would look like. But every day, if you're using this in your environment, you're having thousands of commands that go into the AWS infrastructure. It's all programmatic. So unless you're doing the CLI tool, you're really not seeing it. But what you absolutely can see is the result, meaning the output. So Sean, if you could go on, that would be great.
All right. So essentially what John has talked about, I'm just going to demonstrate. So on the front end, I thought what I would do is just make it really easy to sort of see the kind of commands. If you're not familiar with what the API command line infrastructure or the command line calls that are being made to the AWS API instances, I thought I would run through a couple quick examples. So let me just, for folks on the screen of varying resolution, I thought that maybe I would just make this a little bit bigger, and then from here we can sort of drill down into a couple of these examples. So first off, again, just about everything you want to do inside of AWS you can do through command line API calls or programmatic calls that don't require access to the AWS console. So this would be an example of the AWS console. I've got a bunch of things I can do inside of EC2. They provide you with a really nice interface for point-and-click sort of functionality, but underneath all of this, even the AWS management interface is really making a bunch of programmatic calls via an API layer that sits in between the presentation layer in your web browser and the backend service itself. So what I'm going to do is run a bunch of different commands that are going to be in the EC2 dashboard, if you will, or inside of the EC2 service itself. You could run API commands inside of S3, you could run them inside of Redshift, you could run them inside of RDS. Pretty much all the different services that AWS offers will give you the ability to run CLI commands to them. So just kind of a breakdown, a little bit of an education on what it takes to craft an API call. It's really quite simple. You're really going to need an AWS reference point. So I've already installed the AWS CLI tools inside of my Mac OS X environment. They provide you with a really straightforward process to do that. Essentially, you just need to have Python installed, and if you have Python installed, as most Macs ship with it, you'll be good to go to just be able to install the AWS CLI tools. Now, I've got all that installed. If you're not sure how to do that, AWS provides some really great documentation that you can go to. Just Google AWS CLI, and you'll find it in the first two links there. Basically, what we're doing is we're going to execute a command that calls the AWS CLI to the forefront, which I'm doing here with the word AWS. Then I'm going to the region that I'm going to actually execute the command against. So in my case, I'm going to be doing it against AWS US East 1. Normally, without the X Suite and usually that's going to be provided by you when you set up your IAM account for the given application. In my case, and in our case for this demo, we're actually going to hit the Exedium AWS API service that exists at this endpoint URL that I've specified here. The actual command we're going to run is called EC2 describe instances. And it's really that simple. That breakdown, you'll see I've got some other commands for creating key pairs, describing key pairs, deleting key pairs, setting up a security group in EC2, setting up a VPC security group, describing and then deleting security groups all around the board. So we're going to just run through a couple of these. All right, now I do have, for my API service, I do have a set of credentials that have been given to me so that I can execute against the API service. So what happens, as John alluded to in his conversation, you have to be able to have a set of credentials to be able to use and have all of these API calls sent to the service. So in my case, I'm just going to cat a file that I have on my service, or on my box, and you'll see that my access key ID and the secret access key that I'm allowed to use for the service that Exedium has set up for my account is this swhank with this access key called swhank:2013. Very complex secret key and very complex access key ID. I just shared that with everybody, so I'll probably have to change it as soon as I'm done with this call. What we end up doing also inside of the IAM interface for my account, for my own account that I own inside of AWS, we are required to have this account set up here that references this particular access key ID. So before I'm even able to set up and use the Exedium service, I have to have an AWS IAM account with a certain level of permission and privilege for me to integrate with the API service. So there are just some building blocks and some backend pieces that we need to have in motion. Assuming you have all that in place, it's really point and click simple. So what I'm going to do is just copy this command right from the screen here. And from my command prompt, I'm just going to paste it. And what you're going to see returned as I do this, again, I'm just executing a command that basically says, show me all of the instances. And I've requested the output as a default setting to be in JSON format. So there's a lot of output in here. For example, it gives me information about the particular instance name, any tags that I've got associated with it. Here's the name of the instance as I've called it within my account inside of US East, who the owner of the actual AMI is that's running, right? What the public DNS name is. All of these bits of detail are provided programmatically in the command line response from AWS to the command that I just executed called AWS describe EC2 describe instances. Okay. So again, here's the command, the actual command, and then here's all the buildup. And again, of course, you could configure this such that you could always have a default region. You could always have a specific endpoint URL that you specify. You don't have to spell it out in a command line like I'm doing. However, I thought it would be easier to just show how this works. Here's another example where I'm basically going to do the same thing, but instead of just describing the instances, I really want to describe all of the small instances that are running under my account inside of US East 1. So again, as I run this command, what you're going to see is all of the instances that are running as an M1 small. Okay, same thing, the exact same thing in a visual format inside of the EC2 environment of AWS, right? So from the management console, basically by clicking on, the drop down and specifying the running instances, I'm actually executing on the back end CLI calls to the AWS service to populate this particular view in this browser. Okay, so I got standard instances, high memory instances, high CPU instances. Again, you can kind of filter the results in the GUI. But again, most folks who are command line junkies and really want the efficiency gain from being able to programmatically script these types of interactions with AWS will do so. All right. I'm not going to worry about generating a key pair. I think I can do that for you. But here's one that I will run for you. I'm going to actually run this EC2 Security Group AWS CLI command. And what it's going to do is it's going to create a security group called CLI Security Group, and it's going to give it a description called creating using CLI tools for testing purposes. Now, just so I can show you a before and age, and I'm going to show my EC2 Security Group so you can see it. I only have one group in here at the moment, and allow me to just drag this off screen as I copy this command. And I'm going to turn around and just simply paste it again inside of the command line infrastructure. When I do that, I hit enter, and the response back is going to be very short. The return was true, gave me the group ID, and the request ID that generated it. If I come back over here to that same security group page, and I do a read, what you're going to see is I now have that second security group with the name already provided, CLI_security group, with the description that was just created. So we have a very easy way for adding and removing, instead of having to come in here into the GUI as an example, click on security groups, click on create security group, and then go through the whole routine of having to add, name, field, etc., and use your keyboard and mouse and be able to assign it to VPCs, etc. So having the ability to enter one command, a command line prompt inside of, in my case, OSX Terminal or PuTTY or whatever the environment is that you're working in, makes it a lot easier for developers to be able to configure the routines and the scripts and applications. Similarly, I'm going to run the very same thing, but it's going to be a little bit different. It's the same root of the command, but this time, instead of creating the security group in EC2, what I'm going to do is actually create it inside of my VPC environment. So when I go to the VPC setup and I go to the security groups in the VPC, you'll see I have quite a number of different VPCs here. All right, and I'm just going to slide that off the screen again, and I'll jump back over here, and I'm going to paste the command again. This time, whoop, that's not the right one. Let me copy this. And now let me paste the command. This time again, very similar name. This time I've identified it as VPC, and I've actually specified what VPC I want this particular security group to be created in with the ID. Again, the return, the really important thing here to see is a return prompt of true. that lets me know that it was created. I drag back my Safari browser over here, and I move it over just a bit more to refresh. There you see my CLI security group created with the name with the same description in that field. That's part of the security group already that's been established, or part of the VPC ID that's already been established here. Now, for anything you do inside of the environment, you can also do the reverse. So in this case, I've created two security groups, one in my EC2 instance and one in my VPC. So if I don't want to use the GUI, but I want to be able to describe all those instances, again, copy and paste is your friend here when it comes to doing these kinds of demonstrations. Again, I'm just going to leverage the command and be able to show and describe all of the security groups that are inside of the environment. Obviously, in this kind of an instance, it's a little bit more difficult to read the JSON output on the screen. It makes it a lot easier to see it inside of a browser GUI session formatted like this, but it's the same information. Okay. Now, I will just show one quick demonstration of the remove command. In this case, I'm just going to remove that security group I just created inside of the EC2 instance. And I'm just going to go ahead and do a Command V to paste it, and I'm going to run it. And again, we'll get the return back saying that it was true. When I come back over here, pop back over to my EC2 environment, click on the security groups. Now you see I'm back to a single security group again. So the CLI-based security group I created is no longer there. And one more just for the road. I'm going to do this inside of my VPC as well. I'll just remove the security group. Okay. And notice this time here I got a different kind of a response. It says invalid group not found. Now notice what happened here. In this case, I on purpose have a mismatch of a security group ID. All right. I come back over here, go to my VPC. I will go to the security groups, and here is the VPC, or the security group in the VPC. Now I'm just going to do a little bit of window management here. So you can see on the blue terminal window the security group ID is SG-Delta-Delta-37 Echo 8 Bravo 2. The actual security group that was created inside of AWS is actually Echo 336 Echo 98 Charlie. Now, if I want to actually have the command line remove this for me, I simply just have to select this, and I'm just going to go ahead and paste this security group inside of the CLI, and I'm going to hit enter. Now what you're going to see is, again, I get the return code of true. If I pop back over here to the browser session and I refresh, you'll see that that security group is now gone. Okay, so I'm kind of done showing the commands here. So that's one aspect. That's just a sort of a primer and education on how the CLI works. With the
Hey,
real
Sean.
magic, yes.
So kind of in line, we got a good question. So so there was the comment about that, and I know why you were trying to do so much of it, also giving us some robust logging here. But can you step through at a very high level, at least, what's happening in the back end when you submit those, any of those commands? You're submitting it with, the URL and key pair that we issued out of X Suite. So maybe you can walk through what actually is taking place on the back end.
So the endpoint URL that I ran here, so it's a good question, and I'll do my best to answer it. And John can even provide more color because he helped actually architect and knows probably at a much more intimate level than what I'm going to be able to describe. But I'll give it my shot at a high level. So when we specify this endpoint region, what we're really saying is send the command to the X Suite or Xcedium API Proxy service that's also running as a web app in AWS. What we're in turn doing is validating the user ID and the secret access key that I showed you earlier, right? My name and then my name with the caret 2013. That's being passed to the API proxy service that's run by Xcedium. Okay? Once that credential is received, we're breaking apart the actual command, and we are actually passing a new federated temporary tokenized key back to the AWS CLI with the actual command. So what's happening between what you input in the interface and what's being sent to the API service is an entire process of stripping out all of the what I'll call the temporary tokenized or the exposed tokens that we're using to interface your application to the AWS API service, and then we're actually using the real tokenized credential, the temporary credential, to pass back to AWS. And it might be easier for me to explain when I show the log data, because it'll actually break down and show each step of this process. And to be honest, this is nothing against AWS, but to really understand how AWS works and how these API calls work, it's really good to be able to see the kind of log data that we're going to actually capture and show, because it will really break down the process of what goes on in that environment. Okay, so I don't know if I'm doing a good job there, John. I don't know if you want to add anything to sort of provide maybe a lower level technical explanation as far as what's going on there, but I yield the floor to you if you want to provide any additional color.
Okay, sorry, I was on mute. Yeah, I think that's a pretty good description. I mean, what AWS allows you to do today, without us at all, is interact with their APIs in such a way that you have to create a user and IAM for every single script, every single thing you want to give access to, meaning the Puppet, the Chef, the CLI API, the SDKs. You have to create a separate user for each of those. So first of all, we federate that process. So somebody can log in with their AD credentials, get a key pair from us, and we'll attribute everything they do back to that individual. So we're removing that shared credential, fuzziness when you actually want to see who did what. So that's right off the bat. The second thing we're doing is recording all the traffic. That's not something you can do with AWS. So you don't have a record today of what API commands are done by whom at all in AWS. As well as being able to enforce a specific policy, meaning set of permissions, to a federated user. Now, you could create today in AWS, you could create an IAM user for every single combination of permissions you'd want to give to somebody, and then go and distribute credentials from that IAM user to those individuals. But then you're managing the entire directory repository, separate from AD, separate from whatever you're using today to manage users. We take all that away and say, so you can say, you know what, I have a here's 20 users in dev. I can give them each a set of credentials very, very easily with a setup, and here's what the only things I want them to be able to do. I can do it in one place and have them self-service access to get those credentials, meaning you don't have to distribute anything. Further, you could actually programmatically give those credentials out to them using our and rotate those credentials using our our 8A technology. But the most important aspect is that, in fact, we are not giving them real credentials. They can't circumvent us, so they will be recorded. They will, and of course, be validated against the set of permission policies that you set in our product, so they can only do what you want them to do, no matter what credential that they're deriving from.
Hey, John, can I ask you a question in real time here? This is me. This isn't coming from anyone in the audience, but are you also able to now, instead of having individual IAM accounts and permissions set up for individual applications or users, through the use of our API, you can basically, for all intents and purposes, have a single IAM user for any number of different apps, because we're separating out or segregating out that level of detail, correct?
Yeah, absolutely. We only need, for this to work, and you provide infinite amount of permissions, in combination of permissions, the only thing we need you to do is create one IAM user in AWS that has sufficient privilege to cover the highest level you want to ever assign to anyone, and that's it. What's really great about this is we don't lose attribution. So we will know precisely what script, what SDK, what CLI user did what in AWS, which is the real key to this whole thing, and why, and it's the benefit of being able to record this. So it's not just having a recording or an audit trail, which you certainly do with this. We're enforcing permissions, but most importantly, we're telling you who did it. So you can say, you saw it, you shut this, $10,000 an hour box down, but you mislabeled the ID of the machine, like Sean was showing you an example of, and it's still running, and you didn't realize it. We'll know exactly how that happened, and the command that caused that to happen, for example.
Right. So I think that's a good segue, John, for me to just jump back in here, because again, I'm going to actually show this. So this is my master AWS account, and in my account, I had to actually create this IAM user that I called AWS API Proxy. Right. This is my actual access key for this particular user, and I've got a set of credentials for that guy as well. Now, in order to put this into our service, I had to pass this credential to our API Proxy administration team. They, in turn, created me that temporary SW Hank account. And so from there, I'm just going to jump over to the log service. And what I've done is I've done nothing more than copy and pasted this AWS API Proxy key that's in my account, my access key ID. And I just pasted it in here in a Splunk search utility, and I just am going to do a search. Now, I just ran a bunch of commands. I had 40, I ran some more, now we're up at 68 matching events in the last 7 days. If I streamline this and say in the last 60 minutes, you're still going to see 34 events, and here they are. I get to break them down, in fact, by clicking on these individual charts, and you'll see now I can come down here, and you'll see everywhere where it picked up that AWS access key ID. Now, this is really important because what we're doing is, again, we're getting the log information from the API calls going into AWS and the response back from AWS, giving you both sides of the conversation. So again, it's saying, hey, guess what? We're creating and using a token for SW Hank. This is the policy in our API service. This is the name of the policy that's associated with my access key ID. And we're using this temporary credential for purposes of going from the proxy service back to AWS. Okay? So we're logging that, number one. So not only are we attributing access, we're actually tracking which access key ID is being used. I want to draw your attention to this line number 2 that's right down here. We're actually showing you how we're executing the get federation token, integrating with the AWS STS API, how long that particular token is going to be valid for in seconds, associating that with the user ID and the policy, and again, tying all of that back together here. Notice that even with the credentials, as we log this service, we've actually set it up to redact the actual session token and the secret access key because they're not needed. You can get all the information that you need to know what application or what IAM account actually performed the activity with the logs without ever needing to expose these keys. Again, we're rotating these temporary access tokens every 900 seconds, right? If I scroll further down, you're going to actually see the responses that were taking place. Again, more get federation tokens in the last bit of time. If I go over here to the previous events that I ran earlier today at 2:37, right at 10 minutes ago, 4 events, again, just keying in off of that access key ID. It's really neat, and one of the reasons why I love to play with Splunk. Again, Xcedium's not tied with Splunk. We have no partnership with Splunk. Prospect the ability to leverage 500 megabytes of log data into their freeware version of Splunk today. So it makes a really great, fun tool to use for being able to test the capability out. So if I wanted to, for example, show one of the commands that I ran previously, right, which I believe was delete security group. Okay. If I could type, right here you can see delete security group, and I'm going to show those 9 instances and see how many ran in the last 60 minutes. Now you can actually see, in addition to the command that's highlighted here, you get to actually see the entire layout. Remember I said that I wanted to send this to US East, so there's the region. Here's the access key. Again, this is a tokenized temporary federated access key that comes from the STS integration we've done with the API proxy, redacting the security token, and then being able to drill down and actually see the responses. If I actually view the source of this information, you're going to see a whole ton of actual raw command line that comes from AWS. Okay, and that's what we're showing here. This is the actual raw log input, all of this text that we've captured that you don't normally see by leveraging either just a straight command line or by leveraging just the IAM interface. So there's a lot of rich data that can be captured as a result of leveraging a service that has the ability to interact with and take advantage of all of the security offerings and the capability that AWS provides today. So again, just kind of a real high-level overview of what the API proxy service does. Again, gives you the ability to federate identity and access controls for your applications, as well as give you the ability to log and give you the ability to not have to worry about managing so many IAM accounts for purposes of providing programmatic or application-level access to a particular environment or region in AWS. Pat, back to you.
All right, Sean. Hey, well, we've got, I'm just going back through the questions to make sure we've hit all the answers here. I think we've either answered out to everybody in the audience or covered most of them here. So we'll take a little bit more time here, and if you guys have any further questions, we'll stick around a little while and answer them. So let me give another couple seconds here, and we'll go from there. Thanks for the. It's always better for us to get a bunch of questions, and they came in at opportune times. So thanks for the participation. Well, with that, it looks like we've come to the end of all of our questions. So I'll look back through these and make sure that we get full answers to everything. If not, we'll shoot you out an email. But I think we've disposed of all of them. Anyway, have a great rest of the afternoon. We definitely enjoyed having you here, enjoyed the questions, and wanted to thank Sean and John for sharing the new capability in XSuite with us. And we will look forward. We've got some upcoming webinars after a little bit of an August break. So you can also, if you're going to be at VMworld, come and see us there. We'll be participating in VMworld. Oh, I did get one, John, that you might want to jump in on this. I'll let you. Why don't we get this? Was a question on impact of adding a layer, performance impact of adding a layer into the equation. Do you have any benchmarks?
I answered that directly, but the quick answer that I did, well, the question I saw was, do you have any performance benchmarks? Is that the one you're referring to, or is there a different question?
Yeah, that's it.
I answered that one. So yeah, certainly we have performance benchmarks that we did and that we shared and were conducted also by our QA organization, as well as the ones that we did with AWS, the AWS Solution Architecture team. The short answer is first of all, the performance is outstanding when utilizing this in a real-time mode. You'll see slight variations, and we're talking very slight, and dependent on the EC2 tier that you choose for your API proxy server itself. So we have a minimum requirement which gives you outstanding performance out of the box. But some of our larger customers who are very seasoned utilizing this system, and in fact most of their infrastructure is on AWS's backplane, have found that they use a higher tier of EC2 proxy server, and also of course for load balancing. This on the front end with ELD on the AWS infrastructure. So there is some opportunity to increase the tier of the EC2 device, meaning where the Omni is running in Amazon from a CPU memory core perspective. We haven't published results yet, simply because we want to come up with a matrix for listing out what you'll get with each of the tiers.
Yeah, and this is Sean, from a guy that does a lot of these demonstrations on behalf of prospects and customers that want to check out the new features. I will tell you the fact that our service, this API proxy service, is running inside of AWS as a web app itself, meaning we're taking advantage of all the economies of scale and all the performance integration that's with RDS, with EC2 compute, with auto scaling groups, all of the elastic load balancing. So accessing the API proxy through Xcedium is no different than accessing the AWS service itself when you enter the URL endpoint. The really important distinction there is that we are not running this today. We're not running it as something that needs to be installed in a separate box that goes on your premise. This is literally being operated as a truly scalable global web service that will grow as our customer base grows. So really important to understand, the dynamism that we've got in the product today to be able to scale out and support, very large quantities of API calls coming into AWS.
A question you may have as a result of what Sean said is that this is single tenant, however, meaning you get your own API proxy server. We are not multi-threading API requests with anyone else. So your API proxy server is for you alone, even though we're obviously leveraging the AWS infrastructure for autoscale, which is great. But it's also great to know that your requests aren't being shared within the server with any other company's requests on the server.
Yeah, very, very, very good point. Yeah, there's a separate RDS instance. There's a separate EC2 cluster compute. Everything is separate for any customer that wants this. It's your data remains your data, and there's no chance of it ever being compromised or being cross-pollinated.
That's right.
With data.
You got it.
making the auditors even more happy. Well, with that, we'll wrap up here. Thank you guys for the quick tour today. Certainly, if anybody has any follow-up questions, hit us on the contact us page at Meta, and we'll be at Exceeding. We'll happy to get those any other additional answers out to you. So have a great afternoon, everybody, and keep your eye out for some other upcoming webinars. We've got some, as we said, starting up in September again. Bye now.